The interoperability between geospatial and grid infrastructures intends to solve important problems, especially from Earth observation field. Processing and storing large amounts of data. Performing computationally intensive and complex calculations. Achieving high performances. The geospatial web services are adapted to support different execution flows, either over the web or over the grid. The grid advantages are visible only above a complexity boundary which is estimated by the mediator component. The general interoperability use case is the following. A client makes a request to the OGC service. The request is sent to the gridified version of the OGC service. The gridified service contains a standard OGC service and a mediator component. The mediator component contains a complexity computation module which estimates the complexity of a request. If the request has a low complexity, it is executed over the web and the data is retrieved from a web geospatial database. If the request has a high complexity, it is sent to the splitter module which will divide the request into sub-requests and send them to be executed over the grid. In this case, the data can be retrieved either from a web geospatial database, or from a grid geospatial database. The results of the workers are collected and merged by the merger module. Execution flow. Submit a service request. Analyze the request complexity. If the request has a low complexity, execute it in a standard way, over the web. Obtain the final result and visualize it. If the request has a high complexity, split the request into sub-requests. Create jobs for each sub-request. Execute the jobs over the grid. Collect and merge the results. Obtain the final result and visualize it. Results analysis. The tests have been performed both over the web and over the grid infrastructure. They are meant to emphasize the advantages brought by the grid over a certain complexity boundary. The complexity boundary is represented by the intersection of the two graphics simulating the web and the grid executions. The test variables were the amount of data in the database, number of features in this case, and the number of performed service requests. We have performed tests for 10, 100, 500 and 1000 features in the database. For each case, we have executed a variable number of service requests, 10, 25, 50, 100, 200 and 500 requests respectively. As the number of features in the database increases, the complexity boundary is estimated at a lower number of service requests. The results show that the grid infrastructure is useful especially for large amounts of data and for a high number of service requests. The interoperability between geospatial and grid infrastructures targets data parallelism management, data security, complex execution parallelism. To conclude, the grid advantages are highlighted over a certain complexity boundary which depends also on the amount of data and on the number of requests.